Hey everyone, welcome to Manufacturing Hub. My name is Dave. This guy up here is Vlad. If you guys are new here, welcome. If you've been here before, welcome back. We are an educational show. Every week, just about every Wednesday, you'll see Vlad and my smiling faces where we talk to an interesting guest. Every month we pick a theme. This month we are super happy and excited to jump into a systems integration theme. Before we go ahead and jump in, I want to say happy birthday to my sister Marika. It is her birthday, and sometimes she listens to the show. Vlad, I don't know if I've ever told you this, but they continue to ask when the call-in show segment is going to be, and I continue to tell them not this week. So Marika, it's still not this week that you get to call in. Maybe at some point in the future, we will go ahead and get everyone on, and then it can just be 60 minutes of confusion as to Vlad what all of us do. But no, you guys welcome. As we're going through this, as you guys are watching, kind of our two biggest platforms are LinkedIn and YouTube. Vlad and I are struggling to open up LinkedIn because the services may be down as we go live, but we're going to do our very best to go ahead and get this out live to you guys. As questions come in, please feel free to go ahead and ask those questions either to Shane, who we'll introduce in a moment, Vlad, or myself. We'll do our very best to go ahead and ask those questions here during the live show. If they're super technical, if we can't get to them, if we've got an issue and we can't pull up comments, we will do our very best to go ahead and get back to them afterwards. Without further ado, again, everyone, welcome to Manufacturing Hub. This is episode 156, and all of March 2024, we are kicking off our systems integration theme. Today, we'd like to welcome Shane Dreffs from XYZ Automation. Shane, welcome to the show. Thank you for being here.
Thank you. Glad to be here.
Shane, thank you so much for joining and taking the time today. I think it's going to be a really good conversation around systems integration. But before we dive into that, maybe could you give us a bit of your background? How did you get started in manufacturing automation, and ultimately describe for us what you are doing today?
Yeah, sure. So I started back in the mid '90s. Was pretty interested in robotics. So started off with Fanuc Robotics, became what's called a road warrior for them. So I did a little bit of installation engineer, they call it. So we really kind of set up the cells, ran the cells off, everything electrically, mechanically, got everything ready. Most of that was done at the facility there in Auburn Hills. And then the equipment was then taken, installed into the customer facility. And I did that for a while. And then I moved more into a programming role. So it was a process engineer role. So I started getting some hands-on as far as getting into the robot, doing some programming. I kind of focused at that time. I was mostly in the paint and sealer group. So I did a lot of automotive applications, a lot of painting, sealing on different types of automobiles, pretty much throughout the U.S., some different countries. So I did that for a while, and I'd say about 5 or 6 years, and got a little bit burned out from travel. So I said, okay, well, let's see if I can find somewhere where I'm working more at home every day. So I started working for General Motors for a little while. Did the same thing there. I was doing some as a automation engineer. So I did a lot of work in the paint shop, working with the robots again. And then got this crazy idea to come down south here where we're at now in nice warm Alabama, come down to work for another automotive manufacturer, Mercedes. So we came down, started working here at this facility. Same thing, worked in paint, did a lot of the paint robots. But I realized something pretty quickly is that there wasn't a lot of like a good install base here, I should say, or a good support base of integrators that could actually help as far as robotics, integration on projects that I was working at. And really kind of coming from that previously, I thought, well, hey, why don't I get out there and kind of do it myself? So it was a crazy idea to jump out there and kind of just support the customers here locally. Let's build some relationships. That really took off very well. And then never thought at that time that really kind of turned it into a business, but here we are today. So, we do robotic integrations, support, training, everything from, like I said, like support to full turnkey systems.
If I can ask you just to expand on that a little bit, right? So I'm assuming you're not only programming robotics at this point, but you also program PLCs, and you probably tie that into, like the plant systems. And maybe what was the learning curve like at the time, right? So at least in my experience, a lot of the robotics engineers kind of focus on only robotics, and then the PLC programmers, such as myself, would focus only on like
Yeah.
PLCs and those types of systems. Did you have to like upskill yourself, or did you have to find people that can like bring that skill set? What was the transition to building full like turnkey solutions as an integrator?
Yeah, you hit on it exactly. That's really what I had to do, because coming from a more robotic background, and you're right, there's a lot of I see that kind of changing now, but then there was a lot of separation where it was PLC and robot, right? So
Mhm.
PLC guys did the PLC stuff, robot guys did robot stuff. Well, as I kind of got out there on my own and started doing some work, it was more heavily robotic at that time. So when I first started getting out there and just helping out, I was doing a lot of the robot side of things. Just could be some optimizations, helping support maybe a new model launches, different things like that. So as that got bigger and we got busier, I did start to myself learn a little bit. I picked up some PLC, started doing some of that on my own, but I realized real quickly that there was a pretty steep learning curve, and it made sense for me to start partnering. So kind of as we grew and got more work, we developed some partnerships. Working with, I worked, just try to work with other people that were good at that. So really good, strong PLC or even electrical groups. And we started collaborating, working together. So that's kind of how it started. And then, as that got more and more, we got more and more busier. It's like, okay, now we got to start, building a team, more of people working, within XYZ. So that's when we started hiring and doing that. But yeah, you're definitely right. There was a learning curve there. But that's kind of how we did it as we grew. Just did a lot of that collaboration and working together with other people.
And it's an interesting topic, right? Because I think that many of us want to learn as much as possible, and I think we get excited by the perspective of let's say for me to learn robotics, but I know how deep that rabbit hole can go, and so I
Yeah.
certainly can appreciate that you cannot always have all the not right, and we can expand it to vision systems, we can
Yep.
expand that
Mhm.
to like MES, SCADA, and so there's so many tangents that one can go on. But maybe to bring us back, Shane, to
Yep.
since this is kind of the opening episode for systems integrators, and I know that many of our listeners understand what a systems integrator is, but I
Mhm.
still think it's somewhat of an umbrella term, right? So in many instances, a systems integrator could also be someone developing an app for like the end user, and that's going to be running on your like servers at the MES or ERP levels.
Mhm.
But maybe how do you look at defining a systems integrator? Are there any core principles that you would say would make a systems integrator, or is it very generalized to like software and hardware development?
You're right. It is very broad, right? So there's a lot that can be considered system integration. It really just comes down to the word, kind of what you see, system and integration. You're integrating, right? So you're adding some system or process into another maybe process or a new process. So that's kind of how we define it. And it's where we are, anyways. And we're kind of a little more narrow focused when it comes to like the robotics automation side of it. So not always robots, but that's kind of a general term as well, because a robot, you think of the 6-axis industrial robot, but it could be even like an XYZ gantry or something like that could be doing a process. So that's kind of how we're defining it. What kind of what we do as a system integrator is everything from the conceptual, the idea, the designing of the system, to installing it into the facility, doing a runoff, make sure everything's working correctly. But yeah, you're right. That is a very broad term, because there's other what you could call system integrators, but what we do is a little more narrowed down to the automation side of it.
Gotcha. Dave, what are your thoughts?
Absolutely, Shane. I think that's super interesting. I have a couple of kind of thoughts and questions from that, and especially going and talking about narrowing that down. But first, I want to tell Vlad he missed the perfect opportunity to plug the new Solus PLC robotics course that he has going on. And for our longtime listeners, you'll know that I am the person that I feel like I am the one plugging all of the Solus PLC courses. So checking out solusplc.com. There is a robotics course going on there. And Pavel, who we had on an earlier episode, is the person designing a bunch of those courses. So if you want to dive not quite all the way headfirst deep into robotics, but want to get your feet wet and learn some of the basics, go ahead and check that out. Now that I have fulfilled that contractually agreed upon
Thanks, Dave.
solusplc.com plug, you're welcome, Vlad. Shane, I think it's interesting. I guess I kind of want to dig into what you're doing with robotics. Can you tell us a little bit more? So obviously you started in the automotive, and so I imagine a lot of that was what we think of now as kind of those 6-axis robots. What sort of robotics are you doing now? What sort of applications are you kind of digging into?
Yeah, we're a lot of the applications that we're doing now is and you're right, it was real heavily automotive is kind of where we started, and
Mhm.
those are probably similar applications, similar robots being used. You have a lot of the larger industrial robots. They're moving around parts of the vehicles. You're welding, you're sealing. There's a lot of joining technologies. There's a lot of things like that you're doing. But when we're looking at not just automotive, but we're looking at now taking from that experience because it's very heavily automated. So now we're looking at our customers and saying, okay, there's some non-automotive that are highly manual. So you look at from the automotive background is highly automated, right? There's a lot of robots, but a lot of our customers now, what we're trying to diversify into is helping them automate. So we take our from our background from automotive, and we are using that and helping them take their manual processes and then automating them. Sometimes it's hard to go from a basically full manual to a full automated. So we do something that's called semi-automated, where you still have an interaction of the operators, some human interaction that's doing some part of that process, but now you have a robot that's also doing a part of the process. So, and usually what you look for to do is you want to take away that it could be a very labor intensive, maybe bad ergonomics. It could be a bad environment. So you look at those first, you say, okay, that would be a nice place or a good place to start for the automation. And then you could have an operator that maybe takes a task that's not in the environment like that. Maybe now they can put a part into a fixture, do something like that. And you're taking away some of the heavy lifting or some of the repetition that they may do, and it could be causing injuries or something.
Absolutely. So I like that. I want to go ahead and dig into that more. But I guess kind of before we dig into that more, I guess, Shane, in my experience, I think there is a lot of opportunity to go to that kind of semi-automated stage, but it's a lot of work, right? Like there's work up front to understand the problem and to figure out what the human is doing because you're putting, I don't know, maybe at most a cell in place, and the cell is doing some of the work as opposed to going and putting in an entire line. So can you walk us down the path as to how you came and how XYZ has become a group that helps to do some of the semi-automated work, please?
Yeah. Yeah. So like I told you that we, took from our experience from a highly automated environment, like automotive, and then now we're going to customers now. And sometimes there is this misconception of maybe someone hasn't seen a lot of automation. The first thing they think of is like, oh, robot can do that, but not always. So there's actually some applications that are better for humans to do. So that's what we really do when we first start this process of going into looking at, can we take from that manual and go to maybe a semi-automated? There may be sometimes that it doesn't even make sense, whether it's going to be financially, because it could be very expensive to try to go from that, or just maybe a better application that's suited for a human to do that. There could be a lot of like variations in the application. It's always changing. It's different. Automation likes something to be repetitive, to be the same, or at least close. There could be very complex, small part assemblies, things like that, that a human seeing something and looking at it can easily identify that compared to a robotic automation system would have trouble doing that. So we kind of start there and we look at, okay, does this make sense for an automated process? And then if it does look like, we can get to there, then we start looking at, like you'd mentioned, the complexity of it. It's like, okay, well, it sounds easy sometimes to say, okay, well, a person just does this all day. Let's just throw a robot in there. But you have to look at, like I had mentioned just a minute ago, where automation likes to have something in the same spot every time, right? So how that process works, the flow, like how the part or whatever it is that the robot working with is, how that's presented to the robot, right? So it has to be in a place that's known, the robot can pick it up. And there's some things in there you can look at. We have some with new technologies coming out, there's some visions, some other things that you can look at that's going to help you get to that. But again, you have to, there's that threshold, right, of does it make sense from a cost standpoint to try to automate something that maybe you're not going to get that return, right? You're not going to get that return on investment. So we really want to vet that first, look at that complexity. And then, so once we decide that, hey, this is going to be a good fit for at least a semi-automated process, we start breaking it down into more of understanding of the actual process itself. You know, talk to the customer, what's some of the pain points, what some of the issues they're having. It could be everything from, especially the last couple of years, could be from we just don't have the people, right? We're struggling to have enough people to get the product out the door. So we have to find some way of automating some stuff. It could be ergonomics. It could be, you know, safety issues. Maybe they have a lot of injuries, or it's in a bad environment, like I've mentioned. And a lot of times when you're in like in bad environments like that, your customers tells you that they have a lot of turnover issues. They just can't keep people working in that particular application. So that's another thing we look for, is that, okay, this makes sense, you know, to try to help automate this. So once we kind of get to that level, we start doing a little deeper dive and trying to really understand the scope. We go through that, and then we really start talking about the specifics of the application, the process. So then we look at the actual manual process and say, okay, this is how we're doing it manually. And that, you know, it gives a lot of clues on how we're going to be able to semi-automate it. Because a lot of times you can take how it's being done now and easily transition some of that into an automated. So then we start, we look at that. We look at, you know, what the requirements are, things like cycle times, you know, how fast the product has to be moved. We look at what the product is that the robot has to work with, right? So there's different weight, size, different things like that. So that will dictate, you know, is this a fit for automation as well, or what level of automation? You know, we can size robots and different things like that, and understand what it's going to take. And then usually during that discovery process, you know, we also talk about any specifications, requirements that the customer has. We will identify drawings, schematics, different things that are going to be required for us to start putting something together. And usually the first thing that we do after we get through that phase of it is and that's really what we call an engineering study. So we really kind of break everything down and look at each component of it. And then from that point, we can start to do some concepts to get some ideas of how we're going to do that. And we're working with the customer while we're doing that phase of it. And then really the next step after that is once we kind of get to that conceptual idea and kind of have some proof of concept. There's a lot of things you could do to do a proof of concept. There's a lot of software out now. You can do virtual. So you kind of show how you would actually do that process and show that it's possible, show that how much time it'll take. You can do real life type demonstrations. We have some robots in our facility that we use for that type of thing. We can actually do a demo with a real robot and kind of show. So once we get through the proof of concept phase and you know, everything's looking good, we obviously we've already talked about, you know, is the budget there? That's one thing we want to make sure too. But then we will get more into like a budgetary proposal and to you know, start talking about what the cost would be to do something like that.
What are, I guess, like Shane, if I can ask you, and again, I come from a fairly automated space, and a lot of my projects have mostly been, you know, we have this very old robot and we want to replace it with a newer robot and ultimately upgrade the throughput. I would be the PLC guy that would tie in the robot, you know, into the facility. But my perspective has always been it always comes down to the cost. But at the same time, the facilities have the infrastructure in place to, let's say, like modify the programs, maintain the robot. And from what I understand, you might have some objections maybe on the, you know, like what the maintenance cycles are going to look like, who's going to maybe like modify or add like new SKUs to the robot, like what kind of, like as you get into those conversations, I'm assuming it's not just the cost, but also some of these, I guess, like less tangible discussions. And what are maybe the concerns of the customers you're dealing with are?
Yeah, and that's a lot of what we've been trying to do too, is kind of educate, because you know, sometimes it gets into because what we're doing now is a lot of like manual. You know, there isn't automation, so there's always a question of, can this really happen? Can a robot really do that? Or once this is installed, can we maintain it? Can we, you know, do the work on it? Do we have to hire, you know, engineers? Do we have to hire maintenance people? Do we have to do all that? So that's a lot of the questions that come up. So we have to really kind of educate, and that's really how we design the system as well. So you have to design it from a very maintainable system. So it's not, the end user has to live with it, right? So we want to make it a simplified system. It's easy to program it, easy to maintain it. And that really, I think, once we get to that level and start explaining that, and the customer feels a little bit more comfort level that it's not, they're going to have just this automation equipment and then we leave and then they're stuck with it, right? So there's going to be a support there, and that the system is set up so they can maintain it and take care of it. Like you had mentioned, maintenance, PMs.
Yeah, and I think it's important, right? I think in my experience, I've witnessed projects where you sort of commission the robot and then you don't have a system in place to sort of not only just train the day of, but also support the customer. I think with the journey, because as you said, not all of them are going to have dedicated teams that can, to some extent, reverse engineer almost the code and the platform to be able to make changes. So I think good interfaces and solid training on an ongoing basis makes sense. Let me ask you, maybe like shifting back to, I think we made a couple of comments that there's many tangents that you can go into as a systems integrator, right? And we've mentioned some of them. It could be maybe vision systems to detect those deviations in the process. You can also, like start building a conveying systems, and pretty much like your whole cell is a safety system as well. So there's a lot of, I think, different areas. So I wanted to get your thoughts on, as a systems integrator that's looking to get more work, and I'm sure customers are throwing more and more different work that requires different skill set at you, how to manage maybe what you should be taking on and what you should be declining that is maybe outside of your skill set. So how would you like advise a systems integrator at a certain stage to think about those decisions?
Yeah, what we learned kind of the hard way, since you mentioned that, is it is there's a lot, right? There's a lot going on with automation. There's a lot of things you can do, and it gets to be really easy to say yes to everything because it's fun too. I mean, really, if we're in this automation space and we enjoy doing this, that's what we want to do, right? So, but from a business standpoint, it's not always good sense, right? So what we've been trying to do, because we kind of learned the hard way, is not say yes to everything, but to really become an expert in things that we do good, right? So keep doing more of what we do good and do less of what we don't do good, right? So we want to really focus on that, and that's what we've been doing over the last couple of years. And we find things that we do good. It doesn't have to be a real narrow to, like you say, oh, I only do welding. What we kind of done is not. It's still kind of vague, but it's really automating manual processes, right? It was kind of what we're talking about. So that's what we found that we do very well. And we've tried to focus on that. And then what we'll do is, a lot of times the customer might have something that sounds really cool. It sounds like it would be fun to do, but it's kind of outside of really what we do good. So we partner with other people. So we say, hey, we don't do that, but these guys over here, they're really good at that. They do that very well. And, we've worked with them before. So we'll do that sometimes where we just don't say no, but we say, hey, this other company here, they do that well. And that's worked out good for us because we've partnered a lot where, we may have a little overlap, but we work together well because there may be something that same partner comes across somewhere that they don't do well and we do well. So there's that too, that we work together. So that's what we found. And, and as we're starting to do that, we found that that's really helped us. When you can focus on that, it helps with quite a few things. When you start getting some systems and procedures in place, you get more efficient because you're kind of focused on the things you do good, right? And then if you really get it down to where we'd like to do, we have our own types of certain products that we offer. Then you start talking, and now you're getting down to where you have certain BOM, same parts you use, you can stock them. That becomes more efficient. You can get better pricing. And then once you start becoming an expert too, you get a little more customer loyalty. And then you get really less competition, because once you become that expert and that you've defined and you're doing, then you have your customers coming to you. You're the expert in that field, so you kind of reduce some of your competition. You get some customer loyalty, and then your really from a business standpoint, your margins in that can get better because of what I just said. You can be more efficient. You have a lot of those processes already in place that you've refined and got them now to a point where When you put a system in, you can do it much faster. There's less programming, there's less design time, and you have those components that you'll usually use. So you really understand those, because a lot of what you get into as well as integration, there's so many different manufacturers of products and everything out there that, and they're all could be similar, like you mentioned, like vision. They can be similar, but there's a learning curve there. The software, the interface, a lot of that. So once you start to really narrow down your focus, then you can narrow down to those products you use, and you can get very efficient with them too.
And I think there's something to be said before I pass the mic to Dave about trying to figure out as a systems integrator, maybe I don't want to say to productize, but to maybe figure out like a standard approach to like a cell or something that can be, how to say it, like bundled as a one-off. I think we Dave and I had this conversation over a year ago with a gentleman from House of Robotics or House of Design, if I'm not mistaken. You might know that company. So, and I think they started off as a systems integrator doing robotic cells, and obviously it's very difficult to do one-offs every single time. Or I guess when I say difficult, it has lower margins than if you can reapply that same process or cell, right? And once you can bundle that for multiple customers, then of course you can pretty much like sell those as a package. And I think I don't know if they succeeded at that, but I think they were trying to figure that out. And I'm assuming to some extent every systems integrators is trying to find that opportunity. So I certainly, like, I've heard that before, and I don't think it's an easy challenge, but I think we all want to work in that direction.
Right.
Dave,
No, I agree.
what are your thoughts?
Oh, thank you. Thank you for that, Vlad. I was actually digging it up. So I know exactly who it was from our other robotics conversation, because ironically enough, his name was also Shane. So Shane Dietrich of House of Robotics. I will have to go pull up the episode number. But no, they were going through that, and so we've had a couple of conversations about that, and I think it's interesting. But Shane, I feel like you said a really compelling thing that I want to double down on for our listeners, because I think it's important, right? It's kind of the ability to not say yes to everything, and perhaps the ability to say no. And I love it because I've also kind of come to the point in my career in which I've done things that are not what I would normally do. And I've learned a whole bunch of lessons. And many of those lessons are, I don't particularly want to go do those things on a regular basis. So is there a story? Could you perhaps tell us the path that you and XYZ Automation took in order to get to the, hey, we shouldn't do everything. We should go find, core partners to come help us on some of these larger projects?
Yeah, well, everybody has successes and failures, and so as we grew as a company, there's a lot of bumps in the road. It's a lot of trying to figure everything out, get your systems in place, do all that, and so as we do projects, we always have lessons learned. So we talk about it and we say whether they're good or bad, right? A project might have went bad or a project might have went good, but you can always do better. So we try to have lessons learned all the time. And that's really what started driving that is we started noticing some things. And, as you start tracking and looking how well projects go and looking how good you're doing for margins and how well that, just at the end of the project, how really the feel of the project went, how the customer interaction, how everything went. And it started to really drive us towards, hey, we're better at these things, right? We're doing better at these. Why do we keep doing these things over here? That we have some problems. So, and usually what it turned out to be, honestly, is when, a customer comes to you and you don't want to say no, because you say, well, we're here already. We're doing this one thing. They want us to do that. I don't want to say no, let's help them. But that's always kind of where it's going to bite you, right? Is when you have that second thought that, well, we haven't really done that before. Sure. But so we saw that, started tracking how well we do on projects and saw that those are usually the times that we didn't do so well, right? Whether it was at the end of the project, we just said that wasn't very good from a margin standpoint, or even just, it didn't go very well. So we had to do a lot of extra things to try to, to make it right and do the right thing. And then, that turns into a lot more hours than you thought, or, things like that are going to cost more money. And then that on the other side of it too is not really the best situation for you to be in with your customer, because, you got tight timelines. You want to make sure you don't have any downtime and have any issues. So that could run into the problems there. So that's what really, we started thinking that let's look at doing that, focus on what we do good. And then as we started talking about that, we noticed that there's a few different types of applications and processes that we do. And then we started talking about, well, we're really kind of focused in the Southeast right now. That's where we do a lot of work, but
Yep.
we wanted to grow still. We're still in a path. We want to grow more. And when we started looking at systems, kind of like what you said, Vlad, is that you can almost have a package system that an automation system that you can kind of put together. It can open up your customer base, right? So now you can be nationwide, really, right? So you can have customers that may not be a normal customer. You're gonna be talking to when stuff like we do, where we're there, spend a lot of time on site, and there's a lot that has happened on site. Where if we got a package that we put together, you can really send that to the customer, and then you can do a lot of even just remote, or one person can go there and kind of, finish getting it set up and go through a quick training. And then that opens up your customer base now. So that was another reason why we started saying, hey, this is a good idea to go more on a package type product that we can offer from an automation standpoint.
Absolutely. Shane, I guess I want to go kind of dig in a bit more to what that process looks like as you go from taking the manual processes to the automated or semi-automated process. But I was hoping you'd have an example or a success story that you could share with us, and then we could kind of use that and break it up into the different steps for the audience.
Yeah. I got a good one that this one is really kind of the one that drove what I just mentioned, is to come up with like a packaged type of application. We were doing what's called press brake tending. So it's basically you take big sheets of sheet metal and you put it into this brake press, and it'll put a bend on it, right? So, and that's used in a lot of different industries. Pretty much anything you see that's metal that has bends or something probably was bent on a brake press. So, so we did a couple of those projects, and they went well. One in particular that I like to talk about is, our customer came to us and said, hey, we just bought this brake press, this brand new brake press, but we just don't have the people to run it. We just don't have enough. We've been struggling to get people, and it's really kind of a ergonomic issue, because this particular one is larger than the other ones we've had. So it's gonna be bigger parts we're putting on there. So it takes either two people or one person. And if one person's doing it, then, you could have injuries and things like that. So they said, we really like if you could look at, automating that side of it. So when we talked before about like automate, this one would it still was not fully 100% automated, because what we looked at was, all right, well, so we have the sheets of metal that we have here placed. And the way they stacked them was on pallets, but they're very random. So we looked at, all right, well, one thing you do when you look at an application like that is, how will the robot know, how to pick up that? Because it's very critical that part gets put into the brake press properly, right? So we looked at some vision systems, and we looked at how we could, so that wouldn't really affect their process, how they're doing it now. We could still use that, but put some technology in there and put vision in there, and allow the vision system to tell the robot where that part is at. So to give the offsets and let the robot understand how to pick it up. So what the process that we presented, and actually ended up doing eventually, but was that the product would be loaded in by a forklift driver. They'd load the pallet in, and then it'd be in a position it would lock in. Vision system would look at it, identify the parts. And another thing that they did was, we had an HMI, so the operator could say what part run they're going to run. So the robot knew, what parts that were going to be presented. So then the vision system would look at it. Robot would come over using suction cups or magnets. We had a couple different variations because we had a tool changer. But then it would pick up the part, take it over to the brake press, put the bends on it as required, and then stack it. Well, then that was the other part now that still had to be manual, is now you have a pallet with stacked parts, and then the forklift driver could come over and remove that completed pallet and bring another pallet. So that was one example of, we looked at a fully manual process, and now we semi-automated, because it wasn't 100% automated. There's still a little bit of operator interaction, but it took the operator out of the poor ergonomic condition and put the robot in place of that.
That's a very interesting. Go ahead, Dave. Go ahead.
I guess I would agree with Vlad. I think that's interesting. I guess I've got a couple of questions. I know Vlad has got some questions, so let me get my questions in first.
Okay.
So I think that's interesting, Shane. I guess kind of two buckets of questions, if you will. First, do you remember how many people it would have taken if it was a manual process versus kind of the process that you went to? Is it like four people? Is it like six people worth of labor that is probably very difficult to find and would be at least semi-skilled? Or
Right.
do you remember what those numbers looked like in the process?
Yeah, this would have been 4 people
Okay.
for this process. Yeah.
Absolutely. And then I guess kind of second question is when I think it kind of this semi-automated process as you're describing, I think it's probably easier to accept because you're removing some of those really difficult positions and
Mhm.
it's not fully automated, so it probably significantly reduces the cost. Is that kind of where you guys have gotten to the semi-automated process? And is that why you guys are finding a bunch of success kind of going through the semi-automated state?
Right. Yeah, you're exactly right. There's a threshold there, right, where the cost isn't, you don't get that return, right? So the
Yep.
cost is greater than the benefit you receive back, right? So a lot of our customers look at ROIs, like return on investments. So they have, some are different, but they have numbers they want to achieve for this to be successful. So a lot of times when we come to a customer, their first thing is they just want to automate the whole thing because that's what they first usually want. But once we start breaking it down and look at it, um, the cost, it's not that automation can't do the whole thing fully automated, but it's just the cost prohibits that, right? So,
Yep.
and then once we start talking it over, it does make sense because there may be other areas in the facility that an operator, for example, in this case was the forklift driver. They're not required to be there all the time at this
Mhm.
robot cell. They can do something else. So they like that idea too, where even though there's still some manual intervention, it wasn't required to have personnel there throughout the whole process. And another thing that this actually turned into that was pretty nice is what we call, sometimes you hear lights out automation. Basically
Mhm.
what it is that they found what they could do was load up, a large pallet of the parts on like the end of a first shift, let's say, and then they allow the robot to run while really minimal people are there. So maybe there's just like a skeleton crew, maybe of people in the facility, but not like normally would have production. And they're still able to produce these parts. So that way the robot can run until, basically that pallet's done. And then they come in the next morning, they can remove that finished pallet and then just start over again, add in the new one. So that helped there as well, because not only did they get a benefit from the manpower that was required, but they also were able to run production and produce more parts within one day.
I had some Shane questions, like on the technical implementations maybe of that cell, because I'm curious. I've not worked with sheet metal myself, but I've heard
Yeah.
that it has its complexities, especially for vision systems and in many aspects. So I'm curious, and maybe to expand for the listeners also, what kind of a process it takes to figure out some of these. I want to say like alternatives, right? Because I'm assuming the manufacturer said, well, like we're going to present you the nicest bin. It's always going to be squared. It's always going to be the same location, and then at some point you have to educate them, well, like, hey, this is not necessarily, this is going to be too much variation, so we're going to have to inspect with a vision system, and it's going to add in like, first of all, a cost, but also like an integration cost. And then the second, I guess, like point that you've also mentioned is the whole picking up with suction cups versus like grippers versus maybe like magnets. So I'm curious, as you go through the process of iteration, what do those conversations even look like with the customers, but also how do you make maybe some of those critical decisions for the process?
Yeah, you're right. It's definitely an education process because that's one of the major issues that we run into when we go from a manual process to a semi-automated automated is really educating the customer on that process because the way it has been done for probably a long time is just a product is brought over, a person just picks it up. In this case, with the sheet metal, it doesn't really matter how it's laying there. It doesn't really matter exactly where the pallet is, right? Because somebody knows, hey, I can just come over there and I can pick it up. So, and we did run into some of those situations where we were told, hey, our pallets are all the same, everything comes in here the same. Well, then come to find out it's not, right? So it was some time spent, and we really try to help out that situation by utilizing technology again. So we made sure the vision system that we selected had the ability to not only see where the part is, but also make those adjustments. So if a pallet's not in the right location, or maybe the pallet was a little bigger, a little longer than what it's supposed to be, and the product is not sitting exactly where it is, that we're still able to utilize the technology to do that. Now, it did take some time to tune all that in, because when you go into the project initially, like you'd said, the expectation is, oh, the pallet's going to be the same, everything's going to be like this, and then how the sheet metal is stacked down there. In a perfect world, we were told to stack this way, but of course, something's hanging off one end too much, and then the vision can't really see it because it has more bend. So there was some of that education, but I think that's really part of the going from a manual to semi-automated, is that you work with the customers and you have this education, and usually you can work through it. Whether it's going to be, maybe they change a little bit of their process, they might have to modify something for now how that is actually being presented to the robot, or we can use technology, like I mentioned. We can put something in place to compensate for that, right? So there's kind of a dual role there you can do. You can either the customer may, or the customer might say, I can't really change that, it has to be like that, and that's where we can say, okay, well, let's look at changing maybe the vision system, or doing something a little different to make up for that.
Usually iron out, I guess, those questions way before you start implementing the cell, or do you go through a lot of engineering change orders as you encounter those problems? And again, I'm more curious,
Yeah.
what your approach is, because I know we have listeners who have very small, or pretty much are lone implementers, I would call them that. And so they're probably struggling with same like issues. So I'm curious, how do you approach that? Because I think you said also, it's not always on your side, and it's not always on the customer side. It's almost like a negotiation back and forth, trying to understand like what can be adjusted. So I'm curious if you could elaborate on that, like kind of
Yeah.
dynamic a bit more.
Yeah, no, that's great. Yeah, a lot of that comes from kind of what we mentioned earlier, is the uh, fine tuning as an integrator, what you do right and what you do good. Because once and there are some learning curves, as you start doing different applications and processes. A lot of that you don't know, like you mentioned, right? So a lot of that is doesn't come up, or that discussion doesn't happen. But that's why, like I mentioned, we do the lessons learned, and we always are trying to refine and make the overall process better. And a huge part of that is the upfront work. And what I've found over the years is that the more you spend there, right, the much better the project goes, and the less issues you have in the end. So, and it's kind of funny. It's not even really like a direct ratio, because I found that you really don't have to spend a lot more time up front than if you didn't spend that time. You'd spend probably 5 times, 10 times that after, right? So the little bit of more time you spend up front to work through all that, to really truly understand, ask these questions, will save so much on the backside. Because just from hard knocks, learning that lesson is where we said, okay, let's really make up, like if it's a certain type of application that we've done, worked on, we have a form that we really kind of go through and ask these questions, and make sure that that's done up front, right? So some of the stuff that may get you in the end like that, where something's not the right size, or something's not loaded always the same, those are discussions that we already had.
Gotcha.
But that comes from, like I said, learning that. And then if you do certain integrations, you kind of narrow in on what you do good. You learn that, right, from just doing projects.
I think for me, if I guess like make span on my experience, what helped me a lot is whiteboarding with engineering managers, that have a vision, because I think there's a lot of conceptual hardware and software that will be put into the facility, but it's very difficult to visualize, and I don't think it's worth the time spent like on creating drawings before you understand it
Right.
a bit better.
Yeah.
So I've done a lot of like whiteboarding, like we actually walk through like what do we want to see in the end and where the signals are going to go, at least for me, because I need to understand, all the safety circuits, all the like sensors that we'll be checking. I remember even to the the peanut butter facility, they were telling me how the cases were going to be positioned, right? And I had to like push out a pin that would rotate the cases that the robot would then pick up, but ultimately, the PLC would be controlling kind of the conveying piece. And so I needed to have a visual to understand that a little bit better. So
Oh
that
yeah.
worked for me quite
Oh
well.
no, that's huge for sure. Just going through it, laying it out, and then like I said, once you do the same or similar process over and over again, the good thing about that is you don't really have to do the whiteboard that much anymore, because now you have that from previous to start with, right? So some of that's done already. It may be just a few little tweaks here and there, where the application might be just a little bit different. Because even though we've tried to really focus on what we do well, there's still we still call ourselves custom integrators, because not every project we do is going to be the same as the past one, right? But because we've kind of narrowed it down, it's very, very similar. So let's say 80 or 90% of it might be the same, but the other little 10% might, because of that specific application, maybe a little different. But we have a lot of that already done. But no, I agree with you 100%. The more you can, sometimes I call it a virtual installation, almost, is what we were saying at one point. Is like, if you walk through something, and if you actually were going to do it and kind of go step by step, you catch a lot of things that, just kind of talking about it, or say, yeah, we can put a robot in here, we can mount this on the robot, and the robot will do this process. But once you start really breaking that down, like if you were actually going to do it step by step, and you start noticing some things that, okay, well, what about this? This might cause the problem, or make sure we understand, how this is going to work, or or like the other example about the pallet with the sheet metal. Well, the pallets have to be the same size, because if they're not, then this is going to be a problem. So I think that's definitely a big part of it. Sure, that time up front you spend saves so much.
Absolutely. And I just kind of want to add to that, Shane, to your point, and Vlad, to kind of your point of almost exclusively, the more adamant an end user is on the lack of variability in their process and how they do the same thing every time, the more adamant they are. Once I go in to implement something, the more variance I see. I find that especially kind of in the small to medium manufacturing space, there's just lots of variance, and it's lots of variance that is almost exclusively unintended, right? We don't intend to do things slightly differently every time, but we do things every time, and the more shifts and the more people touching it, kind of the more variance you find, which would make it more and more difficult to go through a robotic process and hit that semi-automated state. I want to go talk about the engineering studies, right? So you
Mhm.
made a really good point, kind of walking us through what an engineering study is. I completely agree that you need to go through the process and do a study of some sort, or do an understanding of what the process is at some sort. So I would like to, one, have you kind of walk us through what that engineering study looks like for you guys. But two, I also want to go talk about another important thing that you touched on that I feel is really important about budget, right? Going in, understanding what a budget looks like, because you can go do an engineering study with the thought of, we're going to go completely solve this process. But if it costs $500,000 and they had
Mhm.
$50,000 of budget, they just wasted the entire engineering study. So can you
Right.
walk us through kind of the engineering study, and having an idea of what the budget or what the problem they want to solve is, and how that's valuable on the front end to be able to give them something that's actually useful on the back end?
Right. Right. No, exactly. And that kind of goes back again. This all kind of hinges around kind of narrowing your focus, and being really good at something, being an expert, right? Because that does help out a lot when you really look at an application. And the very first thing that you really, because there's a misconception a lot of times, and because we're in a lot of industries now, like I mentioned, that don't really have a lot of automation, the understanding of a lot of it is really not there, because even cost, especially cost, because there's a lot of times where you could get online and Google something and say, oh, hey, that robot only cost $25,000. So the expectation of a project, maybe they're thinking maybe 50-60% more than that or something, but that's really a lot more than that, right? There's a lot more that goes into it when you start talking about safety, and your you have different electrical panels and PLCs and the robot and then of arm tooling and the fixturing and all these things that go into it. So there's a lot more. Really, the robot's just really think about it, it's just another component, I guess you say, or another device that's actually in a cell, right? Because that's really what it is. A robot's just another. It's a little more flexible than some, but it really is just another device in there. So it's only one part of the overall cell. So doing that first is really kind of the biggest thing. But that comes back to when you're kind of the expert in what you do, you already have a pretty good understanding of looking at something and understanding what it is and having a, if you want to say, rough ballpark idea of what something might take, right? So, and it's not going to be exact. It'll be a plus or minus, but usually we like to have that conversation first because when we do work, we still do work in automotive. It's a little different conversation because when we deal with somebody in automotive, they already have the kind of understanding, right? They do with a lot of robots. They do a lot of projects. So they already have an idea of what it'll take to do that. But when you go to a more manual or a industry that doesn't use a lot of automation, that education has to come first. We have to have that conversation and talk about it because sometimes there is a little bit of unreal expectations of what something like that will cost. So, we do that first. So we try to have the conversation, make sure that, that's there and that's understood. And then if that's good, then it kind of goes back to what I mentioned before. We start having the conversation about, we look at the process and we really have to vet it even after, we say, okay, there may be a budget there, but really is this process going to work for automation, right? Or is the complexity too great where it should stay a manual, or like we had mentioned before, like a semi-automated where we say, okay, yes, a few of these tasks will work and a few are still going to have to be done manually. So we start to break that down. And then as what Vlad had mentioned earlier is, how do you do that or show that or have that concept, right? So again, that kind of goes back to if you're doing something in that same space that you're good at, then you really have a lot of that to use, right? So we use a lot of tools now that we can use that make it pretty easy, different simulation software, different things like that we can put together something pretty quickly. So once we have that conversation with the customer, we go through it. We really look at the process. We look at what some of the problems that they're having. Because normally if, a customer comes to us and says, hey, I want to automate this, there's a reason, right? Is it going to be, I just don't have the people, I don't have enough labor to support it. I have a lot of turnover because it's a bad environment or bad ergonomics, or there's injuries a lot in this particular application. So we talk about that first because that is a big part of it, right? So if it is, let's say, an injury type thing, ergonomic, but it's not feasible or economically to go fully automated, then we say, okay, well, let's take away that one element that causes those injuries in that, right? So we may still have a operator there or somebody that's interacting with the system, but we're going to remove that portion of it with automation. So that's what we do is kind of our discovery. We kind of go through it, and then we once we get through that, really dive deeper in what I'd call more of the engineering study. And there's a couple ways that we do that. If it's something that is pretty familiar to us that we've done before and the complexity is not that great, then we will continue with that. So we have some concepts and things that we present, and then we talk to the customer about it. We start looking at like I was mentioning before, like cycle times, the weight of the component you're moving, so we can specify the equipment that's going to be needed. Are we conveying something, moving something? Are we, what kind of application is, like maybe welding, gluing, sealing, something like that. So we kind of do a deep dive into that. And then that way we can really kind of start speccing what is going to be required for it, right? So, and then if it gets to a point where it's something that's really complex or something big, we may also do what part of our engineering study is that we will provide like a quotation to the customer and say, okay, well, this is really going to take a lot of work to come up with a simulation, to maybe give you some conceptual drawings, but this proposal will be deducted off the overall cost because we've already done it now, right? So we may do some design work, we may do some preliminary programming, maybe like simulation like I mentioned. We do that first because sometimes that's required because it may be little more complex or a little bit bigger than just to kind of go in and look at it. There'll be a lot of time required, to come up with that. So sometimes we go that route. We do that, and so then we're able to do a really good job of coming up with some conceptual drawings, do the virtual simulations in that, and show how this process will actually happen, right? So the customer sees it. Because again, when we're working with customers that don't have a lot of automation, the biggest thing is them to visualize it, right? To say, okay, can this really be done with automation? And it's understandable, because if they haven't seen it, that's our part, our side of it, to do that education and to actually show that, right? How's that going to happen? So that's usually the process that we go through during our engineering studies, to really collect that data, to do our conceptual drawings, to show how we can do that specific application with automation.
Shane, I'll be honest with you. I'm really curious about the simulation tools. I've seen some kind of rough demos. I've not built one from scratch myself, so I know they're getting more and more used. But if I can elaborate maybe on a higher level question, right? So Dave and I are going to be at Automate later this year, and I know that the trade show obviously has a lot of different solutions, but there is a fairly dominant presence of different robotic solutions, right? So I want to ask you, maybe you as a systems integrator, how do you evaluate? We talked a little bit about customers maybe pushing different ideas onto you, but in this case, you can go and look at different solutions for the robotic systems integrator, whether it is vision systems, it could be simulation tools, it could be AR, VR headsets, it could be monitoring solutions. So I'm curious, maybe how do you evaluate some of these newer tools coming out and sort of saying, well, yes, this sounds like a great solution for us, we should adopt this, and then maybe educate the customer also on those tools, or this is maybe something that's a little bit not ready for the kind of solutions we're looking to offer. I'm really curious, how do you make those decisions, again, based on maybe the trade shows, the OEMs, outside of the customer?
Yeah, it's kind of a mixture of a lot of things, but what we've done is try to build some good relationships and partnerships. And, it's always kind of a funny running joke of how, you got the sales guys that are always, hey, can I come show you this, show you that, bothering you, but not really bothering us. Because what we like to do is say, okay, well, let's have them come in. Let's see what the new technology is, right? Let's look at that, because there may be something we're looking at or we want to do where there might be a better solution there, right? Some new technology or something that may help that. So we try to always stay up on that, whether it's, going to trade shows like you'd mentioned, partnering with a lot of the good manufacturers, a lot of them that we see out there that have the technology or in the application or what we're actually working on. Because that's another thing too. It could be, you have a great manufacturer, some product, maybe like vision, maybe it's more of an inspection that works great for this one application, but now you may be working on something over here. You need robot guidance now. You need a system that'll actually give you offsets or something back to the robot, that'll tell the robot, where it needs to go to. So that may be a completely different manufacturer of a product. So that's what we try to do, is to really, whether it's going to trade shows, whether it's working with a lot of the manufacturers, either have them come in and do demos, or just partner with them and get training with their systems. That's another big thing that we like to do, is to go to their training, to understand their systems, how their interface works, their software. And then we kind of evaluate it from there, because kind of like what I just said, a lot of the manufacturers have done the same thing. They've noticed that, hey, if I'm in this niche, if I do this thing, I'm the expert, I do this good. That's what we look for. We say, okay, well, this company here does this one specific thing really, really good. And we're doing this one thing now. We're going to work with them on that. So that's what we like to do. And then, because it's not always driven by the customer, right? They may, a lot of what we're seeing now is because we are working with a lot of customers that don't have a lot of automation. They really don't know. Right. They don't know, what vision system do I want? What robot do I want? So we evaluate it from, what kind of support, what kind of relationships that we have with different manufacturers. Do they kind of niche, or are they in that specific application that we're looking at for that? Because, at the end of the day, we want to be competitive too. So we want to make sure that we're working with a manufacturer that also we've worked with a lot. We probably can get better pricing because, we use their products, which in turn is going to help the customer too, because we know we can be a little more competitive. So we do, that a couple different ways that we do that, but that's really how we kind of search out and kind of, look through all the different options that are out there. There's a lot, right? There's a lot of, robots, especially when you talk about collaboratives. I mean, they're like, there's new collaborative manufacturer, at every trade show we go, I think we see 5 or 6 more that are, come with these collaboratives. But we try to look at, the longstanding companies, ones that provide really good support that we work well with, because, that's what we're installing to our customers as well. So we want to make sure that when we leave, they have to live with that. So they have a good system that they're going to get good support from. So that's usually, how we do that to kind of narrow it down.
Yeah, it's very interesting to me. Like, again, I think robotics is a space where I think there's so many like highly specialized applications, that let's say again, like I see the big FANUC or KUKA arms that are palletizing or moving, cases from point A to point B, but there's so much more that people are doing, again, in very specific spaces or industries that I'm not personally in. That's why at some of these trade shows, I don't even recognize all the names. And I think there's also, now manufacturers from other countries that are coming in with slight variations, let's say, on the tool. So again, I think there's a lot to see, a lot to learn. But I think from an integrator standpoint, I think it would be difficult to kind of navigate all those nuances and, what does it truly offer besides being, let's say, cheaper or maybe faster. I think those are kind of the obvious metrics, but beyond that, it becomes a little bit difficult. So,
Right.
Dave, what are your thoughts?
Absolutely. So I really appreciate that, Shane. I think that engineering studies, kind of almost whatever you want to call what we're calling an engineering study here, is really important, both because it lets everyone know and understand fully what they're getting into. And for some number of thousands or tens of thousands of dollars, they can go really understand what the implications are and perhaps get some simulation, go get that work done up front, which would almost exclusively cost them multiple times, 2, 3, 5 times more. But I think, kind of as you said, part of that is the need of transparency of, hey, this is why we're doing the project. We really need to understand your pain points. We really need to understand your budget. And the more kind of relationship that two groups have, and sometimes it's hard the first time, right? So like, I would imagine if you're like, hey, I'm Shane, let me come help you solve this problem. I want you to pay me money for a deliverable that you in theory think you should be able to do internally, and I want you to tell me how much you have budgeted. Like, that is a much more difficult conversation than having worked with the group 2 or 3 times in the past and having solved some of their problems. So I think that those are really good points. Now, I will say, if you guys are watching this on LinkedIn playback, because LinkedIn was down during like 2/3 of this conversation, Shane, and I don't think we made the connection. If you guys are watching this on LinkedIn playback, please be sure to go ahead and drop your comments and everything else below. We will do our very best to go ahead and answer them in this playback mode, because again, I think automating manual processes in this entire conversation is super valuable, and it is honestly a really awesome conversation. So thank you for kind of walking us through all of those things, Shane. As you were talking about some of these really good examples, I'm thinking to myself, man, I've had some like really bad examples that I probably can't share live on air just in the last couple of weeks, of the exact opposite series of the conversations that we're having now. So it fills my heart and gives me hope for all of us that that there are good opportunities and groups like what you're doing at XYZ Automation. I do want to go ahead and ask you the questions that we ask all of our guests. And the first one is the one that I think I've got the most fun with, but I want to ask you to go ahead and predict the future. So can you perhaps go ahead and predict the future, either of systems integration and the niches, or the future of what semi-automated manual processes look like, please?
Yeah. Well, I'm not a good future predictor, but I'll give my best shot. But no, I believe that with the way technology is always advancing all the time, and it has been for like a long time, right? So that the opportunities are going to keep growing, right? There's more and more ways now to solve problems. Because if you would have asked me maybe 15 years ago about how we'd approach a project, I would say, like for automation, robotic automation, I'd say spend the most money you can on the fixturing and tooling and put something in the same exact place every single time. Well, when we started looking at the last 3 or 4 years, a lot of customers that want to automate manual processes, it's hard to do that because it's really kind of cost prohibitive, right? It gets really expensive to do that. So Now that technology is advancing how it is, and we're getting a lot of different things like vision and things that we can now add in with automation. It's really helped minimize some of that, right? So the cost can come down a little bit, and there is some issues that can come up with that, but as long as the system's designed correctly and you account for some of the things that can happen, it can be a very robust system. But I would have probably gave you a different answer 15 years ago, but now I believe that's where things are going to start going, and you're seeing more and more of like what I call lights out manufacturing, like I mentioned earlier, because we're seeing that, some of our customers want to do machine tending, right? They want to say, well, I can just put a pile of this raw material right here, and the robot can do its thing, putting these parts into this machine and then unloading it, and I don't have to have somebody right here, right? And I can do that on a second shift or third shift when normally I don't have the production people here to support that. Now I can actually produce more product, right? So I see that growing, and with that, you have things like mobile robots and the technology in robots, and kind of the programming where you had a lot of division between like IT and like PLC programming and that type of like robotic programming is kind of merging, right? You see where robots now, you can do a lot more text programming and do things on HMIs on the actual tablet or the teach bed itself. There's a lot of like SCADA data collection stuff that I see really helping a lot, because a lot of customers really utilize that to help them with downtimes, with maintenance issues, stuff like that. So I kind of see that being a big thing too in the future. That's going to get better. And a lot of that, even what we're seeing now is like remote support, right? We have customers that we can actually remote into their system and help them much faster than years ago. We'd have to drive there, right? So not only you have to have somebody available, then you got to drive there, and then this whole time they're down, right? They need to be running again. So with technology growing and getting better, there's those opportunities now to provide that type of support much faster. And that's going to allow customers to run more efficiently, right? So in turn, they want to do more automation, right? Because you're seeing the benefit from it. They're seeing that, 15, 20 years ago, I'd go into some places and a robot was kind of sitting there tucked off in the corner, and then they're still doing it manually. And I'm like, what happened? Well, I don't know. The robot stopped working and nobody knows how to fix it, and we just turned it off. So, I see now with the technology way it is, with being able to help faster remotely and things like that, I think that's going to help. Some customers aren't going to be so I won't say scared, but just like fed up with automation, right? Because they didn't really know it, but now we can support them faster. So I think all that together, in the future, and hopefully there's more reshoring, more things coming back to the U.S. So it's going to help with the automation here and that growth. But yeah, I see in the future, automation is going to keep growing, and I don't see it slowing down anytime soon.
Absolutely, Nish. And I love that. And that kind of very much leads us to the next question. So we always like to ask for career advice. So if someone is kind of early to mid-career, what is the advice that you would give them, looking as the fact that the next 10 or 15 years is going to probably be very different than the previous 10 to 15 years?
Right. No, I actually like the subject right here because this comes up a lot. I have a lot of people ask me, hey, how do I, get into robotics or automation, or what classes do I have to take, or what do I have to do? But honestly, with the way things are kind of changing, a lot of people don't want to go to a four-year degree, right? They don't want to do that, but they don't really think they have the same opportunities to get in robotics and automation. But there's actually a lot of opportunities. So if somebody doesn't want to go to a four-year degree, there's a lot of things out there, different tech schools that offer like associate's degrees and different things like that, that will give you some of that background knowledge, especially into like mechatronics, and where you're learning a little bit of everything, right? You learn a little bit about pneumatic, hydraulic, little PLC, little robot programming, kind of all mixed in together, where something like that could really have a lot of opportunities, right? So they could go in a lot of different directions, where they might want to be a programmer, maybe robot operator, or something like that. So there's a lot of directions they can go. But even the next step of that, maybe somebody doesn't want to go to school at all. There's like, I'm out of high school, I don't know what I can do, but I like robots or automation. I just think that if somebody like that was to go talk to an integration company explain, hey, I'm willing to start entry level. I'm just, and have that right mindset to just really, put the nose to the grindstone and really just learn. That somebody like that, I believe, after like 10 years, you got somebody maybe coming out of college at a 4-year degree with some of the different degrees out there that people are struggling to get jobs. I think that person would be way ahead because they're not going to have the debt. Yep. They're going to have a lot of education, already have a lot of experience, and they're going to be able to advance their career a lot more. So I think that's kind of changing, right? That there's a lot of opportunities for people. It's really just getting out there and taking that chance, and don't think that it's that difficult. I know a lot of times people are intimidated. Robots or PLCs are really hard. Really not. It's just that mindset, right? To just push yourself and learn it. So that's what I would say. For career advice, that there's a lot of opportunities and doesn't always require to go into school for a 4-year degree. Now you can go for like electrical engineering or something like that, but I still feel there's a lot of opportunities for people that they don't have to go that path and still have good careers.
If I can add to that, Shane, I think there's more and more government subsidized programs, and I know it depends on a state by state basis. I obviously don't know all of them. But I guess the unfortunate side is I don't think they do the best job at advertising those programs. So a lot of people simply don't know unless, they spend the time to research or probably talk to, their school counselor or whatever that looks like. But they are definitely out there. I think there's a lot of almost like free education, even on robotics, where you can come in and learn. I don't know if you're going to be at the same level as if you've spent, 5 years, but you can certainly get your hands on a robot and understand, the fundamentals. So.
Oh, definitely. Yeah, I agree. There's one thing that we've done. We kind of started up another company that is called 𝐀𝐮𝐭𝐤𝐧𝐠, and that was really what we wanted to do with that. Is there's a couple things we want to do, but really the main thing is to get the awareness out there, right? So one thing we've done, we've went to schools, whether it might be like grade schools, it could be high schools, and we take a little collaborative robot with us. It's just a little robot we take around in a cart, and we can show how easy it is to program it, what a robot can do. And especially at the younger grades, because they really get an understanding, they see it. It's not like this big, scary, complicated thing. And it's you can talk about the different career paths and things that you can do. And I think doing things like that and different programs that are out there, like you had mentioned, STEM programs, different things that each state, I know Alabama has a division that offers, free training and things like that. So definitely that's one thing. I think if we all kind of have that same mindset, that to just kind of get the awareness out there and talk about it, whether it's your kids or whatever, to talk about the different careers and different training programs and things that are out there. But that's definitely, like I said, something that we really have been doing a lot lately, because we see that gap between the need for that type of people coming in, that skill set, and then the people that actually are doing that, right? So that gap's growing. There's not enough people coming into it that needs to be. So. But yeah, I definitely think that they're taking advantage of these programs is definitely the first step for sure.
Absolutely. No, thank you for that, Shane. And I know that we talked a bit about 𝐀𝐿robotics and kind of what you guys are doing on the educational forefront. And again, I think that that's very important, and especially going into schools. I think what you guys are doing in Alabama, I know Tim and Amber and Wilborn of TW Controls, they do a bunch of that kind of outreach and going and working with those grades. And as Vlad and I have said, and I think as a lot of our guests have said in the past, it would have been amazing to know that there were all of these opportunities. Like, some people knew about it in college, but some people, even it was a post-college of you kind of stumble into it. So I think it's super important. And I always love to see kind of the eyes of middle school, even sometimes high school, but lots of like middle school kids light up when they see a robot moving and when they get to go do that. I think that that's really special. And the future of what we do is very much dependent upon capturing those guys as the next generation of people who will come in. So Vlad isn't here, 50 years from now with a cane walking over to a PLC machine that he's now programmed for the 7th time, a bit disgruntled because no one else on planet Earth can go ahead and figure it out. There was a moment where I wasn't sure if Vlad was frozen because of the words I was saying, but good news, listening audience, Vlad was not frozen.
There's a comment. I just want to pull this up really quick. Someone saying that UR offers like a fantastic free course online. So I know they're kind of like one of the manufacturers that actually provides this kind of like I think it's UR University, if I'm not mistaken, or Academy, and you can kind of like
Mhm.
look at the interface and understand a little bit better. I've not personally gone through it, but I guess my hope is that more and more OEMs can sort of at least provide the basics so that people at the very least
Yep.
Yep.
understand what the platforms are all about. I think that's a really good initiative on their side.
Yeah, I agree. Yeah, it actually is good training to have on there. We have some of our newer people coming in that will go through that. We have a little collaborative in the back, and they can go through that and kind of learn. And they usually pick up on it pretty quick. So there definitely is some good training out there that really doesn't cost anything for somebody to really start off and to get a good understanding of what robotics and automation actually, is really all about, really.
Absolutely. No, thank you for that, Shane. That was awesome. We do want to ask you for a book recommendation. And yeah, so I'm going to go ahead and let you throw out your book recommendation. You've told us it could be one of a number of things. So I'm going to let you go ahead and throw, and then I want to go hear some more about it, please.
Okay, yeah, I got a couple. I over the last couple of years, I've been doing a lot of audiobooks. I like audiobooks. I listen to a lot of books, but one that I really think is good for business, personal life, whatever, is Extreme Ownership by 𝐀𝐮𝐭𝐬𝐧𝐠. I
Yep.
think it's a great book. There's a lot of good stories in there about the SEALs, and it's really like entertaining as well. Not only do you learn a lot, it's a very, very good educational book to how to implement some things in your own life, but actually it's entertaining too, because you get to learn a lot of things that really happen in war and that, and they take that and put that to real life. So I think that's a good one. And then another one I think I wanted to throw out there, that part of what I kind of talked about in the beginning when we talked, is building a good team. I think is really important for an integration company to be successful. It's not always one person can't do it all, right? I think Vlad asked me, he's like, well, there's a lot with robots, a lot with PLCs. How'd you do that? And I realize you can't, right? You can't do it all and be good at everything. So building that good team and doing that is very important for a integrator. That's what we do here at XYZ. We have a great team of people. We all work together, collaborate together, and work very good. But there's a book, Who Not How, by Dan Sullivan, and it kind of just talks about you can't do everything yourself. And there's always, like, if you say, you don't always want to say, how can I do something? Who can, right? So who's that person that either I can work with or bring on the team, whatever, that we can do this successfully. So I think those are two good books. And of course, a lot of podcasts like the Manufacturing Hub Network, right? So there's a lot of good information out there that's free that I think people should utilize more. Years ago, we didn't have all this. So I think these great podcasts that are out there, like the one around now, is a great another option for people to learn a lot. There's a lot of good free information out there. Just have to get out there and just start doing your research and finding it. So.
I've not listened to the Who Not How book, so I'm gonna pick that one up. I have listened to a lot of the content from Jocko. I've considered going to one of his kind of I think he does in-person coachings, and I think I might have told Dave about this. I've not pulled the trigger on it yet. I think it's not a cheap, how to say it, week. But he's an excellent guy. He has a lot of again, he brings in a lot of his close circle on the podcast as well, and they have really interesting conversations. Something I've probably never experienced, but it's just very interesting to get that kind of a Navy SEAL perspective.
Yeah, his podcast is great. He also has another book. It's called Dichotomy of Leadership. It's kind of like a continuation or maybe even a revision of Extreme Ownership. Either one of them are great books. So yeah.
I tried to listen to the book. I can't take his voice seriously when I listen to the book. That's a me thing. I pick audiobooks at least 50% based upon who and how they are reading the book. And I've tried listening to it. It's been recommended a couple of times. I tried listening to it at least once in the past, and I got like, I don't know, 10 minutes of book time. So like 3 minutes of listening time in. And I'm like, and it could be the fact that I listen to books on like 3 or 4x speed. But I'm like, I cannot take it. I cannot take it seriously enough. At some point, I certainly may sit down and read it. But no, thank you so much for that, Shane. And the last question is who should reach out? How can our listeners help you and what you're doing?
Yeah, like I mentioned before, it's just the collaboration. That's what we like to do, is work with even people in our space. What we do, it's like I said, there's always working together, sharing information, helping each other, successes, failures. I think if we all can collaborate and work together, even if we're really in the same thing. We're integrators, but we all have our specialties that we do. And I think that collaborating and working together is a huge thing. It's going to help benefits a lot, right? So not just the integrators that collaborate, but our customers. I think that's a huge thing. So that's what we try to do a lot. We work with a lot of other integrators or other system partners and things like that. And that's what I'd like to do more. To just have more contact with more companies out there where we can share those successes and failures. And I think that definitely helps everybody.
Absolutely. Shane, thank you so much for being here and chatting with us. Thank you for the chat who found us on places that weren't LinkedIn. If you guys are listening on podcast form or you're listening on the rerun or any of those things, please be sure to go ahead and drop comments below if you're watching it live or watching it on the reruns. Be sure to tag Shane or Vlad or myself in those comments so we can be sure that we go ahead and see them. Always interested to go have conversations with you guys. And yeah, so if you're doing that on the reruns, please go ahead and do that. Make sure that you're following Shane and XYZ Automation for all of the super automating these manual processes that they're doing. Make sure you're following Vlad and myself and the Manufacturing Hub Network. If you guys are listening in podcast form, please remember to do things like and subscribe. We are running a little bit behind, obviously, as we normally do on podcast form. So if you guys want to watch the live shows, be sure to follow us along on LinkedIn or be sure to follow us along on YouTube so you can do that. But until next week, we'll see everyone soon. Thank you. Bye-bye.
Thank you, Shane.